Hello, Algebra 2, Chapter 6, Section 5. We are on now page 4 of the notes. We have this cube root graph that's been pretty well hacked up, changed, modified around that we need to graph and talk about its domain and range. So it's a cube root graph, and the initial suggestion is to graph y equals negative 2 cube root x first. And that's not so bad, really, because you know that it goes through the origin, because the cube root of 0 is 0. And then it also passes through the points, let's see here, 1. If you stick in 1 for cube root, you get negative 2. So 1, negative 2. Notice the scaling is by 2 there. And the points negative 1, that's going to be comma 2. So negative 1, comma 2. Oops. There we go. And it's a cube root graph, so you by now probably have a general sense of this S shape that's going on. Boom. Okay, good times. Now, number 2, note that for y equals negative 2 cube root x plus 3 minus 2, h equals, and pay attention on this one, it's a little bit trickier, h equals negative 3, and k equals negative 2. Most people don't have difficulty with the k, but the h thing is a little bit tricky. You have to remember that it's supposed to be negative inside the radical, so the reason that it's positive inside the radical is because the number itself is negative. So shift the graph left 3 and down 2. The resulting graph passes through the points. Well, let's see here. Now, they first told us about the origin. So if you go left 3 and down 2 from 0, 0, you end up there. Now, the next point they talked about was this point 1 comma negative 2. And we're going to go left 3 and down 2. So this is going to be at negative 2 comma negative 4. That's what you get for going left 3 and down 2 from the point above. And then there is this other point, negative 1, 2. Going left 3 and down 2 would be negative 4, comma 0. I've circled the points that should match up in matching colors. Hey, so we've got these points. Negative 3, negative 2, negative 3, negative 2. Keeping in mind that the scaling is by 2's. Negative 2, negative 4, negative 2, negative 4. And negative 4, 0. Negative 4, 0. And we use those 3 points to go ahead and create that same S shape that we had before, because the graph we want, which is the red one, is the same shape as the one we started with, which is the blue one. It's just been translated. Finally, from the graph, you can see that the domain and range of the function are both all real numbers. Boom. Or, of course, if you want to just look fly, you write the R like that instead. All right, good times. So that's it there. Now there's this checkpoint here. There's not necessarily a whole lot of room here, and I'm going to continue with the suggestion of graphing the simpler function first. So negative 1/2 square root x would be the simpler thing to graph first. Starts at the origin, starts at 0, 0, and it goes upside down, and the point is 1 comma negative 1/2, and then 4 comma negative 1. Those are the easy, relatively nice numbers for a square root graph. So that's the basic one. And then because of this plus 3 inside the square root for the one we actually want, that means it's going to go left 3. And because of the plus 2 outside the square root, it's going to go up 2. So I'm going to take the points from before and move them left 3 and up 2. And draw that same square root graph shape. And those are meant to be exactly the same shape, just in different spots. I think we need to talk about the domain and the range as well. So for the domain, remember, domain is the issue about the x's that work. Of course, we're talking about on the actual graph. So all the numbers greater than or equal to -3. And then the range is the set of y numbers that work. And so the y numbers on the actual graph, the red graph, is all the y's that are less than or equal to 2. So you do need to have the graph for our answer, and you need to have the domain and the range information as well. If we look at number 4 on this checkpoint, instead, it's a cube root. The idea is to go ahead and graph that simpler cube root first. So it's 3 times the cube root of x. Now, cube root goes through the origin, and then normally has the point 1, 1, but because of that 3, it'll have the point 1, 3, and -1, -3. And then you can go ahead and make the general S shape of a cube root graph. But for this one, there's nothing additional underneath that radical, so it moves right 0, or I suppose if you wanted left 0. The point is it doesn't move left or right at all. But because of this plus 2 outside, the graph does need to move up 2. So I'm going to take each of those points and move them left or right 0, which is extremely boring, but then also up 2. Now the scale, as you probably have noticed by now, is a little bit funky. It's by 2's instead of by 1's, but nothing you can't handle. And you see you have the exact same shape as before, just slightly higher. Now, finally, we have this domain and range issue. So for the domain is the set of all x's. Cube root graphs, like all cube root graphs, the domain is all real numbers, and the range is also all real numbers, although you get bonus dork or geek or awesome, whatever, same thing, points for writing domain is reals, range is reals. So or maybe that one's okay, and this one's okay with stars on the outside because it's better. Whatever. I'm making too big a deal out of it. Anyway, that's the end of the checkpoint. That's the end of page 4. And that's the end of the notes for section 5. Thank you for watching.